ladies and gentlemen, and welcome to another exciting class with Mr. Simplicity. I want to appreciate you guys so much for the encouragement thus far and bringing us another video. So let's look at the topic for today is implicit function. And as usual, I'm trying to make it as easy as possible. Okay. First of all, we need to understand what implicit function is for us to be able to do implicit differentiation. An implicit function is simply a function, usually an equation, where two variables are mixed up in an equation, okay, such that separating them is difficult, or separating them makes the differentiation more complex. So we have to differentiate them like that, okay. Like the example we have on the board says if x squared plus y squared minus 2y is 3, find the y dx. So if you observe, we have x squared, y squared, and 2y mixed up in this equation. So the only way we can differentiate this easily is to follow the process of implicit differentiation. Let's see this example. Solution: x squared plus y squared minus 2y is 3. So like I said, the first thing to do is to differentiate each term. Let's differentiate 3 by, or rather with respect to x. Differentiate 3 with respect to x. Okay? So when we do that, we apply our usual differentiation procedures. We already did the rules of differentiation in the previous video. If you've not watched those videos, please go back and watch them so that you understand what we're doing here. Okay? So if I differentiate x squared, it's going to give me 2x. Polynomial differentiation. If I differentiate y squared, it's going to give me 2y. Polynomial differentiation. But this is the unique thing about implicit function. I'm differentiating with respect to x. So any variable that is not x that I differentiate, I'll put down the answer and I'm going to attach the y dx, which means multiply by the y dx. So this 2y is going to have y dx. So we move to the next, minus 2y. If I differentiate minus 2y, it's going to give me minus 2. So I'm going to attach the y dx. 3 is a constant. Whenever you differentiate a constant, you get 0. You see? It's kind of straightforward for the first step. Differentiating each term, when you meet a variable that is not x, you differentiate, multiply or add, attach the y dx to it. So next, we're going to make the y dx stay on the left. We have two terms carrying the y dx, so we leave them on the left. So I have 2y dy over dx minus 2 dy over dx. Okay, then we have 2x cross to the other side, giving us minus 2x. So like I said, when you put the y dx to one side, what it does is that it allows you factorize the y dx out of the expression on the left. So if I do that, now I'm going to have dy over dx into 2y minus 2 equal to minus 2x. Now it's easier to make the y dx subject of the formula. I just need to divide through by this guy. If I do that, I have dy over dx equal to minus 2x over 2y minus 2. So this is my answer, except that 2 is common in each term here. So since 2 is common, I can factorize. So I have 2 into minus x into 2 into y minus 1. So when you cancel that 2, you have your answer. That's the answer for this question. Okay. So just take your time, go through the video again and see my explanation. If it's not clear, feel free to answer your question comment section below. So let's take another example. Okay, so let's take a look at this next example. The example says that if we should find dy dx if x cubed minus y cubed minus 3axy is 0. Okay, so let's see the solution. Solution says, question says x cubed minus y cubed minus 3axy is 0. So differentiating with respect to x, we have 3x squared minus 3y squared dy dx minus, so the third term here is a combination of x and y variables. So I cannot differentiate it direct the way I differentiated the other because we have a product of two different variables. So what I need to do whenever x and y are multiplying as a term in an implicit function, what I need to do is to differentiate them by product rule. And remember what product rule says. It says if y is uv, then the dy dx will be equals to v du dx plus u dx. What this expression simply means is leave the second, differentiate the first, plus leave the first, differentiate the second. That's what this expression means. You can also interchange it to be leave the first, differentiate the second, plus leave the second, differentiate the first. That's what product rule mean. If we don't want to go and start saying let u be this, differentiate, let v be this, differentiate like we did in the previous video. Okay, so just follow closely, you understand what I'm doing, how I'm applying the product rule to this expression. So first of all, our u is 3as. So you separate them where the x and y meet. That's the best way to separate. If I separate it, I have 3ax as one term and I have y as the second term. So this is u and y is v. So if I follow the differentiation, it says v du dx. So in brackets, the bracket is necessary because the minus sign. V, which is y, du dx, which is differentiate 3as. 3a is a constant. So when you differentiate a constant x, it gives you the constant. So I have 3a. Plus, leave the first. The first now is 3ax. Then differentiate the second, y. Anytime we differentiate y, we attach dy dx. And y is 1 when you differentiate, so it will be dy dx. Times dy dx. Okay? So all I need to do now is to open the bracket and simplify. So if I do that, it will have 3x squared minus 3y squared dy over dx minus 3a times y will give me 3ay. 3a minus plus is minus. 3ax times dy dx will give me 3ax dx. Everything okay. This should 0 remains 0. So this is what we do. At this point, we can now move to the step that says let dy dx stay on the left. So let's say collecting dy dx together on the left. If I do that, that means I'm going to have minus 3y squared y over dx minus 3ax dy over dx equal to, these two guys will cross. We don't have dy dx. So let's cross the negative one first so that we can start with a positive 3ay. 3x squared cross, we have a negative 3x. If you like, even from here, you can divide through by 3. It's okay. Get it? Okay, but I want to get to my final answer. Y dx. Dy dx. What is remaining is minus 3y squared minus 3x equal to 3ay minus 3x squared. Okay. So I make the y dx solely of the formula now. That will be equals to 3ay minus 3x squared over minus 3y squared minus 3. So 3 is common in all the term, so we can factorize 3 brackets ay minus x squared over 3 bracket minus y squared, or let me bring out minus 3 brackets y squared plus ex. So when 3 cancel out, then the negative stay at the numerator. So in case you are wondering why I took this minus sign up, it's always ideal to leave the negative sign at the numerator in a situation like this. Okay, or just put it on the same line as the fraction line. So this is our final answer for this implicit differentiation. If you're confused at any point, ask your question in the comment section below. Have a nice day.